Okay, example number 3. We're asked to prove cosine of t over 1 minus sine of t equals 1 plus sine of t over cosine of t. Okay, so now which one's more complicated? Well, they both look similarly complicated. So I'm just going to pick the one on the left. Okay, so I'm going to bring this down. We've got cosine of t over 1 minus sine of t. Okay, now this one's tricky. Now, just looking at this for the first time, I would not see what direction to go in to get from here to here. But having practiced these, and the best way to master trig proofs is to practice over and over again, proving these trig identities. I see kind of a similarity here in the 1 minus sine of t and 1 plus sine of t, and then I've got cosine in both of these. Now I know that if I were to make this a difference of squares on the bottom, then I know 1 minus sine squared of t is cosine squared of t. So that's my best bet right now. So one tool that you have is to use difference of squares to your advantage. Even if you've just got one piece of one factor of a difference of squares, then multiply by the conjugate of that piece. Okay, and make that difference of squares happen. So this is going to be 1 minus, let me go down a little bit. One minus sine squared of t on the bottom, and then on the top it's going to be, if I distribute, we're going to have cosine of t plus cosine of t sine of t. And that is cosine of t, not cost. Okay? So now I can replace this from my Pythagorean identity with cosine squared of t. So I've got cosine, and I might should have left this cosine of t factored out. Okay, and seeing that this is our goal, it would make sense to leave it factored out like that. Okay, so now we've got cosine squared of t. So now notice we've got one factor of cosine in the top, two factors of cosine in the bottom. So this one we can get rid of. And this is really cosine of t times cosine of t. So we can slash through one of those factors. And what we have left is 1 plus sine of t over cosine of t, which is exactly what we were asked to prove. Okay, again, step by step, logically equivalent expressions until we get to the other side of our equation. Okay, example number 4, last example we're going to do together, it says prove sine to the 5th of x times cosine squared of x equals, in parentheses, cosine squared of x minus 2 cosine to the 4th of x plus cosine to the 6th of x, close parentheses, times sine of x. Wow, this is a good one. Okay, so now this side definitely looks more complicated, so I'm going to start here and try to manipulate this one until it looks like this side here. Okay, so I'm going to rewrite this, and I'm going to rewrite it. I'm going to put the sign in the front, and I'm going to go ahead and I see that cosine squared is a factor of each of all three of these terms here, so I'm going to go ahead and factor out a cosine squared. Okay, and again, keeping this in mind, this is what I want it to look like when I get down to the end. This is already, just by moving this to the front, and by factoring out that cosine square, this is already looking good. Okay, and then factoring out cosine square, that's going to be 1 minus, and I'll leave that. 1 minus 2 cosine squared of x plus cosine to the 4th of x. Okay, so now we got to deal with this beast. So this looks like real similar to a quadratic expression, quadratic trinomial. I'll bet we can factor this. So if we bring down these two, I'll bet we can factor this as the product of two binomials, where 1 is our first term, cosine squared is going to be our second term, and since this term is positive, we're going to have the same sign. This term's negative, we're going to have negative signs. Does that work? That's that. Inside, outside. Okay, that looks good to me. Okay, so we've got sine of x times cosine squared of x times 1 minus cosine squared of x times 1 minus cosine squared of x. Now, do these look familiar? I hope so. Anytime you see this, light bulb should go off. You should think Pythagorean identity. This is the same as sine squared of x. So let's replace both of these with sine squared of x. So bring these down. Sine of x, cosine squared of x. This becomes sine squared of x. This becomes sine squared of x. Okay, we've got a product of all these, so let's group all of our signs together. We've got 1, 2, 3, 4, 5 factors of sine. So we've got sine to the 5th of x. We've got 2 factors of cosine of x. Okay, that's exactly what we were asked to prove that this is equal to. So that is where we should say that is equal to same thing. Okay, again, you're not done until you have manipulated one side of the equation to make it look like the other. Okay, so here are 3 more identities I'd like for you to prove. So jot these down in your notes. Make sure you give yourself some space to work these out. We'll talk about these in class, in next class, and make sure that you copy down that list of general strategies for solving proofs on the website.